Well, hello, students. I'm now going to present a little bit of a tutorial for clipping the national land cover data to the Pleasant Creek watershed, and then for how to symbolize that and understand what those national land cover data values mean, and then for how to determine how land cover has changed over the 20 years of the two data sets, or sorry, 30 years of the two data sets that you received in Lab 3. Okay, so you can see that I have the Pleasant Creek watershed here, along with the clipped areas of 2023 and 1993 land cover, and we can see differences for sure. These data are produced, I believe, from composite of Landsat data during the same time of year each year by the USGS and other agencies. And so we can see kind of how the land is changing due to development, changes in fires and forests, and desertification and other processes. And so we want to look at how things are changing in this watershed. That's our overarching goal. I've pulled up this watershed right here, actually using something called stream stats, um, rather than going through the whole hydrology tools um, thing that you all did for your lab. And so I wanted to just briefly mention that here. So in StreamSats, we can basically generate a watershed upstream of a point that you click along a stream using some streaming data service, um, probably using something like a 30-meter digital elevation model that underlies this. So I'm going to clear this basin really quickly just to show you what I did. So in streamstats.usgs.gov, you can zoom in to a certain level. And once you can see, if we click to delineate, we click along Pleasant Creek. Let's see, not quite working at the moment. Okay, so there you can see that we've zoomed in far enough that we get the kind of pixels of the flow accumulation interpolation of the watershed. And so we would then click on one of those pixels. It kind of has to be on those pixels, so be careful about that. And then it will generate a watershed upstream, which you could then download. And so this is a much faster process, but it's doing all of the same kinds of uh, processes that you did for your hydrology tools analysis in ArcGIS Pro. What will be different is that this is always going to use kind of this baseline data that's behind this streaming service. And so it might not be the quality of a LiDAR data set. It might not give you a very good watershed if you're looking at a sub-catchment. But if you're looking at a catchment or a watershed, rather, of something the size of Pleasant Creek, this is a fine way to get your watershed boundary. And you can do more with this service. I believe generate hydrography and stream profiles as well. But again, if you want more detail, LiDAR analyses, a small sub-catchment, you may want to go back and do what we did in this lab. So you can then download that basin as a shapefile or a KML and other files it can bring into GIS programs. So that's what I did there. Okay, so here we have it. The first thing we're going to want to do is clip to the geometry of the watershed. So we go to geoprocessing tools and we go into data management, raster, raster processing, clip raster. You can also type clip raster up here, but this is where we're at. And so we can input 2023. We want to output to the extent of the watershed, which I brought in, which generically was called Global Watershed. Probably better to rename that, but I have not. And then we probably want to edit the name here because we can see that it's not saying the year. So I'm going to call it Pleasant Creek 2023 National Land Cover Data NLCD. And the key thing in this analysis, this clipping, is that you choose this box right here. Use input features for clipping geometry. If you don't do that, you will always get a square when clipping a raster. Rasters love to be rectangles, I should say. So click that if you want a cookie cutter view, which is what we want to do, because we want to analyze the land cover only in that feature. Okay, so we'll run that. And it has created a new data set right there. So we want to do that again. And now I'm going to go to 1993. I'm going to change the name to reflect that. 1993 NLCD Pleasant Creek. And I'll run it again. So now I have both of those. I can turn off those larger ones. They look kind of muted because I have a transparency on my watershed. I'll turn that off now that we have it clipped. What are the values underlying these? They look kind of weird. It's like these values, 0 to 254. They're 8-bit numbers. So that's nice and simple to store. Many different land cover classifications, makes the data set smaller, but we need a key to understand what that means. And because I clipped this data when I gave it to you, I lost that key. So how do we get that key back? So in your announcements, Kaya has shared, and I've shared with you a link for a streaming service that you can bring this data in to your ArcGIS program and then use their key to understand what your data are showing. Because the key for each year of the NLCD is going to be the same. Okay. So I'll accept their cookies. What I would suggest is you should be able to like view the API or the data source. I was having some issues with that, so I'm going to click on this Open in ArcGIS Online, and then I could, if I click this button, it says Open ArcGIS Pro. It'll open a new ArcGIS Pro and open the data set. But instead of that, since I already have ArcGIS Pro open, I'm going to go to this image source, which if we look at actually has down here a big file path, a web path. I'm going to copy that link address, and there's many of these sorts of things. If you find online ArcGIS, ArcGIS Online sources, you should be able to open them up and stream them on your map. So we just go back to map, click add data from a path. And then I paste that path in here, and it's this ArcGIS server web service. And I say, go ahead and do that. And then I get a national land cover data set, which has the key. Okay, it's appeared on top of those other data, so I'm going to move it below. It's from a different year. So if you wanted, you could say that that was from 2019, which it was. I don't actually even want to look at that data. I just want to look at the information here because it's a lot better than what I have under there. So let's change these so that we know what they mean. So we will go to the symbology for 1993, and we're going to change it to unique values and ask if it wants to build the attribute table, and we do. There's our unique values. This is already better, right? We don't have 255 numbers. So we want to do that for the other data set too. Unique values, build attribute table, yes. And now we have that. And I tried to copy these values directly into here, and I was not getting that to work. So I would suggest that you instead just type open water. Boom, there it is, right? And copy that as you see, but be careful because the next item down is the National Land Cover Perennial Snow and Ice. I don't have that color in this data set. I have developed, open space. So I'm going to Maybe this is why it didn't copy properly, because they're not one-to-one open space, okay? And we can keep going, okay? I'm not going to do this all in front of you now, but that's what I would do so you kind of know what's going on and you can symbolize things well in your map outputs. Okay, so hopefully you get that idea. We'd want to do that for both data sets. It seems like we should just be able to go import from the other layer, import color map, but it wasn't quite working, unfortunately for me. You might be able to figure that out. But we can at least get it down to just these symbols. We can symbolize them correctly by copying these values here. And this is for a nationwide, so these are all of the land cover classes. Open water, snow, developed open space, developed low intensity, developed medium intensity, developed high intensity, barren land, deciduous, forest, evergreen forest, mixed forest, shrub and scrub, herbaceous, hay and pasture, cultivated crops, woody wetlands, and emergent herbaceous wetlands. And the colors are all equivalent through these datas by the number, which is good. Okay, so that's fine. You'll do that. I'm going to minimize that. But how do you tell how land cover's changed? So I always like to have the more recent stuff on top. We can see if we zoom in here that land cover has changed, right? Turn them on and off. We can see that that green over here, which is 42, which what does that mean? Evergreen looks like. Um, so it seems like that might have increased over those 30 years. And also some things over here have changed, right? We have some 82 cultivated crops have gone up, and hay and pasture has also maybe gone up. But not a lot of changes, but we've got some, and we probably see some more along this road over here. And also, so we're seeing maybe shifts in some of the ecosystems up here in the higher topography, a little bit. Okay, so what do we do to look at difference? You might think that we are going to subtract them, and you could, but since the values are all so weird, 95 minus 90, the outputs would be things like 5 or negative 5. And if it's a different thing, like it can't change between 90 and 82, then we get 8 or negative 8. Those are going to be some weird numbers to interpret, and there may be non-unique solutions uh, where you can't tell what's going on. So I don't recommend that you just straight up subtract them. Uh, the only part that would make intuitive sense to you out of that would be where they were the same because they would be 0. So here's my suggested other approach. We will go to geoprocessing and we will go to raster calculator under spatial analyst tools. And that's under, sorry, map algebra, raster calculator. Well, let's do a conditional, and we'll say conditional 1993 is double equals the same. Oh, we have to go on the other side of this. Double equals 2003. Then we'll give 1. So that's where they're the same. Actually, let's give 0. That makes more sense to me. So 1993 equals 2003, 0. If it's not equal, we'll call it 1, change, okay? And so this will be NLCD 30-year change underscore, no change underscore change, NC underscore C. That's my formatting. Okay, run that. So we can see that most of this is purple. which is 0, no change. And then the green areas are where it's changed, the values of 1. We could change then purple to be no color. And then we can see through that. So that's maybe not the most intuitive because we see everything. Okay, so let's go back to a different color. Okay, so red, no change. Okay, let's do green, no change, because that's kind of intuitive, very neutral. Maybe gray. Gray, no change. Change we'll call red. So there's a change map. Okay, but what we don't know is where this change took place, what happened. We can look, right? In 2023, it's more forested. In 1993, it was more whatever that color is, 50, shrub or maybe mixed forest. So it was classified differently. So it appears to have changed. Okay, so so we can examine it like that. We also saw big changes over here, remember, with the agriculture, but some of it's the same, gray. Okay, so what can we do? So we can say we can examine those original data where the change took place. Okay, so we can go back to raster calculator. We can say now we can go into a conditional statement. Conditional, that thing we just created, and no change change, where that is equal to 1 change, that is, we can give the value that it was in 1993. And so that will tell us what it was before the change. And then we can do another one for after the change. And you might think of a better way to do this, but so we'll call this now Pleasant Creek land cover change. So Pleasant Creek underscore NLCD change C or let's see, how do we want to do that? LCC, land cover change. Pleasant Creek underscore land cover change 93 value. So what was it before? Run. Okay. So now we can see that we have the values pulling from 1993. The colors are not the same. So we got to be careful here. So I would say one thing we first want to do probably is go back to symbology. We've got our unique values there, but we want to probably import them from that 93 data set. Hopefully this works. Okay, yeah, it does. So this shows us where it changed in the past, right? And we still got that gray showing up from before because, and then it shows the areas of pixels of change and what it was before in 1993, right? So in 1993, these areas were more kind of pasture and things. Is that correct? Let's turn this off. Yeah. So we've got pasture and cultivated stuff. We turn on 2023. I said that'd be wrong before, right? It changes to something else. And so this has captured that well. Okay, so then we would go back to geoprocessing. raster calculator. We do another conditional, and we go back to that no change change, and we'd go back on this side of the comma where it is equal to 1 again. We are now going to give the values afterwards of 2023. And so now we want to say this is Pleasant Creek land cover change 23 value. So now I turn on my gray. So now we can see, we can flip back and forth between the two colors and their values. Oh, but I haven't done something again. Remember, these values change colors, so we need to map the color charts again. So the new one that we added, 23, doesn't have the right colors. So let's import from a layer. And I'm going to import it from the 2023. Should be right. And so it pulled in my symbology explanation as well. Okay. So now if we turn them on and off, we can see what's happened. Okay, the color scheme is a little hard to see with the gray at this point. So now I'm going to turn off these old ones as well as this. And we almost want this over a super neutral background that will really stand out. White is probably a good answer. Yeah, that's better, right? Okay, so you see big areas of change up there. Wherever there's change, these should be flipping colors, right? So we did it. Okay. So now what does this all mean? How do we start to make sense of it? Because we're going to see so many different types of little change. We could get really into the weeds there and say in this area, how much change from this to that. I'm not going to ask you to do that in this lab. I want you to tell me the bulk change. And so let's see what we can do. So if we go to one of these, you can see the values, okay? But if we look under here, we should be able to also look at a histogram, I believe. So if we go to the attribute table, we can see the count of pixels that were open water in 1993 that changed to something else. So we lost 3 pixels of water. What is 3 pixels? So these are 30-meter pixels. So that's 30 square meters. So we lost 3 of those. So 90 square meters. So value 52 was the big change down there. And 52 shrub and scrub. So a lot of things were shrub and scrub in 1993 and have gone to something else. Okay. And the question is, what did they go to? And that's a little tricky, but yeah, we can start to do it by looking at maybe making some histograms. I think that would be a good approach. Let's explore that. So if we take the value and the count, and we want the values to be discrete is the problem with this histogram. And so we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different bins or land cover classes. So this should make them, 14 is better. Okay, so, but that is not helpful. You might want to pull this data into Excel to do this better. But you get the idea. What were the main land cover classes that changed, and how much area of them was lost in this one? And in this one, it's kind of like, what did things go to? So if we open up the attribute table for this other one, we can see that actually water, there's more of it. So in 2023, there was quite a bit of water as compared to 1993. There was huge dry period, I think, in that 93 time. 42 is a lot bigger. 42 is what? 42 is kind of more evergreen and deciduous forests. 41 and 42 here. 43 is a mixed forest. That's not as high. 52 is that kind of shrub and scrub. So a lot of things did go to shrub and scrub, but if you compare, a lot more were in shrub and scrub in 1993. And then this is like 7,000 less converted to that. So definitely over the whole watershed lost shrub and scrub and gained those kind of more evergreen or deciduous forest. 42 was bigger than 43. And actually we lost 43 evergreen and went to more deciduous. So we can see the deciduous forest is getting bigger. So what you might want to do is actually just put these graphics beside each other. So this shows the values of areas of change in 1993 and compare that directly to 2023. What percentage of these areas of change were each land cover type in the one and then the other? And that kind of shows you where the direction of change is in this ecosystem. And so I think you can work with that to proceed forward. So do those conditional statements, extract the values where things have changed, and then compare that data and try to summarize it and synthesize what you find there. It's going to take you making sure to put qualitative data in here, not just the number 42, something that makes sense to show that with time we've gotten more of 42. Uh, is that evergreen forest, deciduous forest? We had to make sure we get that right. So probably want to name these properly first. So 42 is actually evergreen forest. So 42 went up. Okay. Yeah. All right, so be careful about that because I was getting a little confused there, but hopefully you see the process. All right, so I'll stop this video. Hopefully this helps.